This part 2 is actually going to be a really short one, and it's got to be one of my favorite tests to use, okay, whenever I have a particular class of series. And it's called the p-test, okay? It's a particular case of the divergence test, all right? Remember that the divergence test tells you nothing about convergence, okay? But this particular version does, all right? So we got a few examples here, okay? We're going to determine if these series converge or not. We're going to have some justification for our answer. And we're going to go ahead and use the so-called p-test, okay? The p-series test, okay? And so here's what the p-series test is, okay? So the sum here, and I'm going to go ahead and omit the indices here, but we're going to assume that, n starts from at least 1 or further on, okay? If I have the sum here, and I'm summing 1 over n to the p, this sum converges if and only if p is strictly bigger than 1. This is powerful, okay? This is powerful. All right, so if I have a sum that looks like that, where it's just like 1 over n to the p, or it looks like polynomial over polynomial, and I can reduce it to 1 over n to the p, and the exponent, the leading exponent, is bigger than 1, even just a tiny bit bigger than 1, like 1 plus 10 to the minus 92, okay? Just a tiny, tiny bit. Then the sum converges. So how does that help us? Well, let's look at that first one, right? 1 over n square root n. Okay, well, let's remember that, okay, that the square root is actually a 1/2 exponent, right? So if I write this here, sum from n equals 1 to infinity, 1 over n square root n, and that's a terrible sigma, okay? So remember that square root of n is just n to the 1/2, and I have n times n to the 1/2. How do I work with that? I add the exponents when I multiply, right? 1 plus a half is 3 over 2. And take a look. 3 over 2 is certainly bigger than 1, okay? Since 3 over 2 is strictly bigger than 1, the sum converges. Powerful, isn't it? Right? Just look at the dominating exponents and then boom, you got it. Okay, well, how about this one here? 1 over the cube root of n to the 4th? Well, let's use some more exponent tricks here. Okay, we're going to go ahead and write this. All right, as, well, okay, cube root, that just means to 1/3 power. And remember that when I have, let's just write this here, okay? I have the cube root of x to the p, that's the same as x to the p over q here, all right? So here p is 4, q is 3. So I have 1 over n to the 4/3. Oh, isn't that nice, right? 4/3, 4 over 3, 4/3. Bigger than 1, the sum converges. Isn't this nice, right? Let's look at this funky one here, right? N to the pi over n to the e. Well, if you know something about those numbers, right? Pi and e, you can probably get yourself a result here. Well, let's look here, right? So we're going to go ahead and sum here. Okay. N to the pi over n to the e. Okay. And by the way, when I write this here, when it says n greater than or equal to 1, that just means the same as summing from n equals 1 to infinity. So same thing. Okay. Well, remember, when I divide, I subtract the exponents. N to the pi minus e. Huh. Do I know something about those numbers? Right. Okay. Remember, pi, okay, is 3.14159265535 and so on, right? And what about e, right? E is 2.71828 and stuff. Well, you can probably estimate the difference, right? Okay. Take a look here. Pi minus e, okay? If you guess estimate, even with the first two decimal places, right? 3.14 minus 2.71, that's certainly less than 1, okay? Because this is less than 1. So the sum diverges. Okay, and we're done. Okay, and we're done. This is a very nice case of the divergence test where we can actually get some information about conversions. But this is only when I have polynomial type things happening. Okay, and so what do we really do here? Do some exponent manipulation, right? N square root n, that's just n to the 3 over 2. Okay, the cube root of n to the fourth, that's n to the 4 over 3. And all I'm just looking for is if that leading exponent in the denominator is strictly bigger than 1. Okay, but here, n to the pi over n to the e, well, that gives me like n to the something less than 1, so the sum diverges. So this wasn't too bad, right? Just looking at polynomials, looking at dominating terms. This can be a very powerful thing, especially when we talk about the limit comparison test moving on, okay, in a future video. Okay, in the next video for this section, we're going to go ahead and talk about the integral test. It's something that we can use, okay? It's kind of like this p-test, it's kind of like this divergence test, but there's a lot, and that one's going to be a bit, all right? So, hope you're ready for that, and hope you had fun with this and this p-series test, okay? This p-test, all right? I'll see you in the next one.